Dr. Nardi here, back with another video. And in this video, I'm going to talk briefly about reliability and validity, why they're important, why you should care about them, and how they fit in to research and statistics. Stay tuned. All right. So I first want to start off talking about reliability. Now, when you think about reliability, what comes to your mind? The way traditionally people think about reliability is consistency over time. So if I give you an IQ test at time point A, you should roughly get the same IQ score at time point B, because we know IQ does not change. So your intelligence quotient does not change over your lifetime, with the exception of some kind of brain damage or stroke. Generally speaking, IQ is stable. So if your test is reliable, then it can be consistent over time. And the other way to look at it is if your scale at home, you all have scales at home. And if you get on that scale today, and you get it on that scale tomorrow, if you get on that scale in a week, if it's a reliable scale, it'll be consistent. Now, a lot of people confuse reliability and validity, and they're not necessarily the same thing. Reliability is different because it does not reflect if you're measuring what you're intending to measure. Because with validity, it's all about, are you measuring what you're intending to measure? So for example, let's say you go to the doctor and you have an appointment with your doctor, and your doctor says, okay, I'd like you to step on that scale over there. I'm going to get your blood pressure. Now you all should realize, oh my gosh, that is not a good metric for blood pressure. That's an actual measure of weight. So it would not be a valid measure of blood pressure because it's not measuring what it's intending to measure. Now, the other thing that comes up a lot in research is something called an observed score and something called a true score. Now, an observed score is what you actually get on a test. So if you take a test in class and you get your grade back and it's an 85%, or an 89%, or a 65%. If you didn't study, you got a 45. That's the score you got on your paper. However, there is something called a true score, and that's 100% accurate reflection of what you actually know. Now, usually your observed score and your true score are never the same. There's always a difference between your true score and your observed score because no test is 100% accurate. There's error that creeps into our tests. Whether your professor or the test you're taking has a bad question in it, or maybe you didn't sleep the night before, or maybe you just got in a fight with your significant other or your parents, that could affect how well you do on a test. So often we're stuck with the observed score when we're trying to get at the true score. Now, how we kind of think about it is your observed score is really your true score, that hypothetical score, plus error. And again, we will never know what your true score is. It's like a pie in the sky. It's very aspirational. We can't know what it is. But we can get your observed score. And I'll tell you this, the lower the error, the more accurate your true score will be. And as I mentioned earlier, sources of error impact your observed score. It could be you're in a bad mood. It could be the temperature of the room. Maybe it's too hot for you. Maybe it's too cold for you. Maybe the lighting is very dim. Maybe you didn't have your second cup of coffee for the day. There could be a lot of things affecting you, but again, we try to minimize error as much as we can to get at that true score, even though we'll never technically get all the way there. Now, there are certain types of reliability that we can talk about. And by the way, if your test is reliable, that'll help you reduce some error. So you get closer to that true score. The same thing with validity. If your test is valid, that'll help you get to that true score. The couple types of reliability I want to talk about today, and there's different types, is test-retest reliability. And this is kind of what I mentioned earlier in the video. Is your test valid over time? So if you get a score at time point 1 on that IQ test, it should be roughly the same at time point 2. The other type of reliability is called parallel forms. And that's if you want to know if several different forms of a test are reliable or equivalent. So let's say that you're giving a test in your class, and or maybe you had a professor that does this. They hand out a paper, and you get Form A and Form B. You have to write down which form you have. Now, if these are reliable, at least parallel forms, they should be roughly equivalent or roughly equal. Another example would be, let's say that I have one version of an IQ test that I developed, like the WISC, and then there's another version, the Stanford Binet IQ test. You want to see if those two forms are reliable with each other. There's a couple other reliabilities that we could talk about as well, and that's internal consistency reliability. And you want to know if items on your test are assessing one and only one dimension. So let's say, for example, you have a depression and anxiety inventory. Well, you want to make sure that the depression questions are only assessing depression, and the anxiety questions are only measuring anxiety. And in psychology, we call these hypothetical constructs. So you want to make sure that the test is measuring the dimensions it's supposed to measure. And you don't want to have like random questions thrown in there. Like if you're trying to test for depression and you're asking questions about happiness, that would not be have high internal consistency. The other type of reliability is called inter-rater reliability. And this often happens when you have two raters judging something, and you want to see if they reach the same outcome. Often they might have a checklist. They might plan ahead of time. It's kind of like judges, right, at a competition like the Olympics. Are you going to get consistent ratings across the board if they're looking for the same thing? That's what inter-rater reliability is all about. Now, in statistics, in research, we actually can get numbers. And we can actually get what they call reliability coefficients. And reliability coefficients are positive. They're never negative. And generally speaking, the larger the number, the better. If something has a 1, that means it's perfectly reliable. You don't really see it that often. And if it's a 0, that means there's no reliability. And what we want is we want to trend towards that more reliable direction. We want to get closer to that 1. How can you get closer to that 1? Well, what you can do is standardize the instructions. They often call that standardized testing, and all that means is all the instructions are the same for everybody. So maybe you read a piece of paper with the instructions on it. Maybe the person stands in front of the room and reads the instructions to you. But that's a great way to just make sure everybody's getting the same directions and you're not influencing them inadvertently as the teacher or the professor. Or if you're doing a research study, you're not influencing them as the researcher. The other way you could do it is increase the number of items. Generally speaking, the bigger the pool of items you have on a certain topic or a certain dimension, like for depression or anxiety, the more reliable your test will be. The other thing you can do is delete unclear items. Often you can do that with the pilot test. You can give this test out to multiple people, to different people, get feedback on it, and ask people, do these questions make sense? And if they don't, throw them out. If you're thinking about testing in schools, don't make a test too hard or too easy. You want to find a balance there, because if it's too easy, everybody will get an A and it won't really discriminate against learners. And if it's too hard, everybody will fail, so that won't work either. And the other thing you could do, whether you're in a research setting or in a school setting, is you reduce external distractions. So make sure that the environment is quiet as much as you can. Now, if you're doing an experiment, you can have the room quiet, right? And no distractions. If you have a classroom of students and you're giving a test to them, you can make sure the classroom is quiet and nobody's talking, everybody's cell phones off. Again, all these apply whether you're doing a research study or you're working with students in a classroom. The other thing I want to talk about today is validity. And again, validity is the idea of the test measuring what you're intending to measure. And the three most common types of validity are content validity, criterion validity, and construct validity. Content validity is really thinking about are you kind of being representative of the all possible combination of items on your test? If you're looking at depression, are you actually asking depression items? Or if you're giving a test in school and you want to know about U.S. history for 8th graders, are you asking appropriate questions for 8th graders in U.S. history? And all that you do to establish this is you get a content expert often. If you're not the content expert, you could find somebody or partner with somebody. The other thing you could do is make sure that if you're giving for example, if this is for educators and you want to do content validity, then maybe you want to make sure that, does your test line up to what you taught them? If you're taught the whole lesson on, the U.S. Civil War, are the questions on your test representative of that lesson? And do you have enough items to really establish validity? Because if you only ask one question, that's not really valid. You have to ask multiple items to kind of assess a topic, a construct, right? An idea. Now, criterion validity is interesting because we have two different forms. We have concurrent criterion validity and we have predictive criterion validity. Now, predictive criterion validity, I'll start with that one, is how well somebody will do in the future. You might have taken this. You've taken an SAT, a GRE, an LSAT, an MCAT. All those are to assess how well you'll do in the future. So if I let you into my graduate program, I give you the GRE, that should give me an indication if you're going to pass and do well. If you take the SATs, that should indicate how well you'll do in college, right? So those are predictive validity. And by the way, all those measures have pretty good predictive validity. Now, concurrent validity is how well you are doing right now in this current moment. And there's different ways to establish this. Let's say, for example, that I have a cooking class. And let's say that I give you a written test on how you bake a cake. And then I actually make you do a performance review and actually bake the cake for me. That would be a type of concurrent validity. Can you actually, is your outcome, actually baking the cake, consistent with the written test, right? So usually you have some criterion that exists right now, and then you make someone do something else to see if it's consistent over time. So how well do you kind of do in the moment is what we care about. And then construct validity is really how well does your test, whether it's a personality test or looking at depression or an intelligence test or a test about aggression or just a test in school like a math test. Is it kind of looking at the construct that you're trying to get at? So for example, if you're doing a test on depression, are the questions lining up with the hypothetical construct of depression? Now, assessing construct validity can be very, very challenging. Sometimes what researchers do is, like, for example, if I'm going to give you an aggression inventory, and if you indicate that student is aggressive or that person is aggressive, do they correlate with actual behaviors? And do they not correlate with behaviors that are not related? So, like, if I was giving a kid an aggressive, aggression inventory, and I could look at if they are aggressive towards other students, if they punch them, if they, yell at them, and so on and so forth, those would be correlated with aggression. Now, if the kid's quiet and very polite, those would be uncorrelated behaviors. So again, this is probably the hardest one to kind of get at because we're looking at psychological constructs, and these are hypothetical ideas. And sometimes these are very, very hard to assess. Okay, So what if you can't establish validity? Short answer, you throw your test in the trash. I'm kidding. Don't do that. You probably will have to rewrite your test, start all over again, or get a content expert potentially. Look at your theoretical rationale that kind of underlines the test. You're going to need to rework it because you need to have a valid test. Validity is super important when it comes to testing. And it's going to be a work in progress. And it takes time to create valid and reliable instruments. It takes time, it takes pilot testing, and it could take years. And one last thing I want to leave you with is a test can be reliable, but not valid. So something can be consistent over time, but not valid. For example, the example I gave you earlier when you go to the doctor's office and they tell you to stand on the scale over there to get your blood pressure, that's a reliable measure of weight, but it's not a valid measure of blood pressure. So something can be reliable, but not valid. But a test cannot be valid unless it's reliable. Because if a test does what it's supposed to, then it has to do it consistently to work. Anyway, that's all I got for you today. Please like, subscribe, and share this video. I will see you all next time. Take care. Bye for now.